Okay, good day Max Sci students and grade 8 students in geometry. So we're going to continue with our third module. So our third module is all about the sum of angles and different polygons. So that's a review. And then we're going to continue the topic or our topic about the congruence of different types of triangles. But instead of SSS or side-side-side triangle congruence postulate and side-angle-side or SAS triangle congruence postulate, we will now move forward with ASA and AAS congruence triangle congruence postulate, or the angle side angle and the angle side triangle congruence postulates. But before that, okay, so let's try to review some of the formulas, okay, some of the formulas that we have learned, okay, in finding the sum of angles in different polygons. Okay, so if we can recall, on module 3 on the first quarter, we discussed a lot about polygons. Okay, and what we have here are 3 different types of polygons. So we have here a pentagon, an octagon, and an irregular dodecagon. Okay, so let's count 1, 2, 3, 4. Oh no, it's an irregular decagon because that's 10 sides. Okay, so it's kind of like also star. Okay, so we have here the following okay, so we have here, guys, the following polygons, and we all know that they have special properties, and those properties are defined by their number of sides, okay, the number of triangles formed inside of the specific polygon, the sum of the interior angle measurement, the sum of the exterior angle measurement, the individual interior angle measurement, the individual exterior angle measurement, and their number of diagonals. So let's say, for example, we take into account pentagon ABCDE. Okay, so we took account of this regular pentagon that we have here. Okay, so we have here pentagon ABCDE, and we want to know the values of this specific pentagon given the following properties. Its number of sides, okay, number of sides, number of triangles formed inside of the polygon, sum of interior angle measurement of the pentagon, sum of the exterior angle measurement of the pentagon, the individual interior angle measurement, the individual exterior angle measurement, and the number of diagonals. So we all know that the number of sides of the polygon is simply 5. Okay, and the number of triangles formed is n minus 2. So that's simply 5 minus 2, so that's going to be simply 3. So that means there are 3 triangles that we can form inside of the pentagon. Okay, so what's the sum of the interior angle measurement? So that's going to be 180, okay, times 3, and that will give you 540, is that right? Okay, 540 degrees. Okay, so the sum of the interior angle measurements of the given pentagon here on our left side, okay, so it's 540 degrees. And the sum of the interior angle measurement, exterior angle measurements of any type of polygon is always going to be equal to 360 degrees. And the individual interior angle measurement, so we simply put here 180 times 3 divided by the number of sides. So there are 5 sides here. Okay, so to get that, okay, so we can okay, 180 times 3, so that's again 540 divided by 5. Therefore, the sum, the individual interior angle measurements of the pentagon is 108 degrees. Okay, so that means angle A, angle B, angle C, angle D, and angle E measure 108 degrees. How about the individual exterior angle measurement? So we simply divide the total or the sum of the exterior angle measurement of any polygon or a pentagon and divide it by the number of its sides, which is 5. So 360 divided by 5, okay, so we get 72 degrees. Okay, so that means that the exterior angle measurement, okay, so if this is the interior angle, then this is the exterior angle. So the interior angle here measures 108 degrees and the exterior angle measures 72 degrees. So this is all just a review from our previous module on the third module, okay? And the number of diagonals that it has is going to be 5 times 5 minus 3, which is 2, divided by 2. Okay, and just simply cancel that, and therefore the number of diagonals that this pentagon has, or any type of pentagon, it has 5 diagonals. Okay, so that's 1, 2, 3, 4, and then 5. Okay, so we formed 5 diagonals. Okay, so these values are very important, especially the angles, because we're going to use these properties or use these angles in proving triangle congruence or congruences of triangles involving two types of triangles by using ASA and AAS triangle congruence postulate. Okay, so we have all of our values checked here. Okay, good job. Okay, so here, guys, for example, we have here a pentagon A, B, C, D, E, and we divided the specific pentagon into 5 different parts. Okay, so, and let's say we have a central point there that we can call point P. Okay, so point P is at the center. Okay, so therefore we've created 5 triangles, triangle APE, triangle EPD, triangle BPC, triangle CPB, and triangle BPA. And we can say that all of those 5 triangles are congruent because this is a regular pentagon. So how can we say that? Okay, so one of the ways that we can try to prove the congruence of the, let's say, 2 triangles. Okay, so let's say we want to prove the congruence of APB, triangle APB, and triangle APE. So we can do that, okay? We can do that by using the ASA and the AAS congruence postulate. Okay, so ASA essentially stands for angle, side, angle. Okay, so we have here the angle, 54 degrees. Okay, we have here 2 angles, and then the side measurement. Okay, so remember, guys, that the regular pentagon has congruent side measurements, okay, for all of its sides. So that means AE, ED, CD, BC, and AB all have the same side measurements, or they are congruent. Okay, and so this is ASA, so we have 54 degrees. This side measurement is congruent to this side, and the angle here is also 54 degrees. So how did we get 54 degrees? As we have solved earlier, the individual interior angle measurements is 108 degrees. Is that right? Okay, so that means angle B, angle C, and all of the angles here measure 108 degrees. So therefore, if this is 108 degrees, we simply divide that to 2, okay, 108 divided by 2, and then we get 54. Okay, so if this is 54, this must also be 54 degrees, and this must also be 54 degrees after dividing this angle into 2 congruent angles. And therefore, by ASA, or angle side triangle congruence, we prove that APE is congruent to APB, okay, because they have there that one angle, then another angle, and an included side that are all congruent, okay, or their corresponding parts, or the corresponding parts of their congruent triangle, of the congruent triangles, are congruent. Okay, so that leads us to our main lesson here. So angle, side, angle congruence postulate. So when 2 angles and their included side, okay, so this is very important, the included side of one triangle are congruent to the 2 angles and the included side of another triangle, then the 2 triangles are said to be congruent. So we have here triangles VTS, okay, VTS, okay, and triangle CAI, okay, triangle CAI. So we can say that triangle A and T are congruent, okay, since they are corresponding sides, okay, so T and A. And also, we can say that angle S and I are congruent, okay, given, okay, so this is given that triangle VTS and triangle CAI are congruent, okay, so that must mean their corresponding sides must also be congruent, and that also goes the same for side ST and side AI, or side IA, okay. Okay, so we have here a problem. Okay, so we're going to try to use the ASA triangle congruence postulate to solve or to prove a given problem, or to find the proof for a given geometry problem for triangles. So Ma'am Francesca wants to measure the width of Pasig River using her knowledge of congruent triangles. Okay, so that's Ma'am Francesca at the riverbank, or near Pasig River. So she stood on the riverbank and extended her field of vision until she saw the edge of the opposite bank. She then turned and found a spot on her side of the river with her estimating eye. Her field of vision is illustrated below. So we have here the illustration of her field of vision. So this is her field of vision extending here to point D, and on the other side of the riverbank it extended to point R. And we have here we drew a segment here, FJ. So given here that angle FJD, okay, so angle FJD and FJR are right angles. Okay, so given that FJD, okay, so let's try to use green here, FJD. The FJD and FJR are right angles. Okay, so given that they're right angles, and given also that JFD, okay, so JFD, this angle is congruent to JFR. Okay, so let's use a red color. Okay, so JFD is congruent to JFR. We want to prove, okay, we want to prove that segment JD is the same or has the same measurement as JR, or they are congruent. So how do we do that? So again, guys, we use the two-column proof. Okay, and for writing our statements, so we write here first our given. Okay, so for the statement here in our given, we have here FJD and FJR are right angles. Okay, so wait, let's delete that. Okay, so FJD and FJR are right angles. Okay, so that's a given. Okay, so we can write that as a given. Okay, and we can arrange them. Okay, so guys, what do you think will be the second statement for this one, and the second proof, or the second reason? Okay, so let's try to find out. Okay, and we also have another given here, very useful information. JFD is congruent to JFR, so those two angles are congruent. So we can write that. Okay, so wait a minute. Okay, so triangles, let's try to delete this. Okay, so angles JFD, okay, angles JFD and JFR are congruent. Okay, and the reason, okay, so its reason is also given, since they are given information. Okay, so going back to the illustration, again, what we want to prove is that segment JD is congruent to segment JR. And we all know that we can only prove that if those two triangles are congruent through the CTCTC, or the congruent parts of congruent triangles are congruent. Okay, so we have here the third statement. Okay, so we can say, based on the figure that we have here, that FJ, okay, that FJ, okay, FJ is congruent to FJ. So let's write that. Okay, so FJ, segment FJ is congruent to FJ. Okay, that, and the reason for that, as we all know, is reflexive property of congruence. Okay, so let's put that here. Okay. Okay. And then, okay, let's go back here to our problem, okay, to our illustration. So again, guys, we have here our two angles that are congruent, so JFD and JFR, and also we have here the right angles. And it was stated that angles FJD and FJR are right angles on the first part. Then therefore, we can state at number 4 that angles FJD and FJR are congruent. Okay, so why are they congruent? Because our right angles are congruent. So all right angles are congruent to each other. Okay, so we've already established, or we've already proven that these two angles here are the same, and the two angles at the bottom of or adjacent to FJ are also the same, or congruent. So therefore, we can say, okay, here on number 5, okay, number 5, that triangles, okay, Okay, triangles FJD and FJR. Okay, so we can say that triangles FJD and triangle FJR are congruent through the angle side angle triangle congruence postulate. Okay, since the angle side and angle are the same, and therefore we can conclude here. Okay, we can conclude that JD is congruent to JR through CP/CTC, or congruent parts